Hello everyone! In this interactivity, we're going to see a worked example regarding Newton's second law of motion. The question asks, a rocket of mass 50,000 kilograms is acted on by the forces shown. The upward force, the thrust, which is equals to 1,400,000 newtons, the downward force, which is the weight and drag, equals to 600,000 newtons. So let's calculate its acceleration. Try to solve it on your own first. Now let's check the answer. First of all, we're going to find the resultant force acting on the rocket. The positive direction is going to be the upward force. So the resultant upward force is equals to the upward force acting on the rocket due to the thrust, subtracted from the downward force acting on the rocket due to the weight and drag. So 1,400,000 newtons minus 600,000 newtons equals to 800,000 newtons. Step 2, we're going to calculate the rocket's acceleration. The resultant force is equals to the mass multiplied by the acceleration. The mass of the rocket is known, and the force is calculated as well as the resultant force. So we need to find the acceleration. We will rearrange this equation to determine the acceleration. So if F divided by m is equals to the acceleration, then we will substitute the values and solve the equation to find the acceleration. So the acceleration will be equals to 800,000 newtons, which is the resultant upward force, divided by the mass of the rocket, which is given in the question, equals to 50,000 kilograms. So the answer will be 16 meters per second squared. So the rocket has an acceleration of 16 meters per second squared. Note that the equation F equals m times a only applies when the mass of the object is constant. In this case, we can apply the equation even though the rocket's mass is changing. Why is this? Yes, we are calculating the mass of the rocket at a time's instant, so we only need to know its mass at that instant.